You ever pull on a t-shirt and notice it feels totally different when it's damp? Well, there's this amazing invisible force at work in the threads of your clothes every time they get wet. It's a kind of secret science, and today we're going to unravel that exact mystery. And it all leads to this one question that honestly sounds like a complete riddle. How in the world can a fabric become waterproof just by getting wet? I mean, it seems like it should be the opposite, right? But believe it or not, the answer is hiding at the microscopic level. All right, so let's dive right in. This whole incredible phenomenon boils down to a single concept: fiber swelling. And trust me, it's happening all the time in all kinds of fabrics, and it is way more powerful than you probably think. So what even is it? Well, swelling is pretty much what it sounds like. It's what happens when a single tiny fiber soaks up water. And as those water molecules rush in, the fiber physically changes. It gets fatter, sometimes a tiny bit longer, and its whole volume just expands. Now, to really understand this, scientists measure the change in a few key ways. They look at the change in width, that's called transverse swelling. They check out the change in length, or axial swelling, and of course the total change in volume. And as we're about to find out, not all fibers swell the same way. Not even close. Okay, but what's really cool is why this even happens. To get it, we have to zoom in. I'm talking way, way in, past the fabric, past the thread, all the way down to the molecules that make up a single fiber. And here's the secret. It's all about architecture. It really just comes down to how these long molecular chains are arranged inside that fiber. Are they packed together all neat and tidy, or are they kind of all over the place? You know what? Think of it like spaghetti. Seriously, in a tightly packed fiber, the molecules are like a box of uncooked spaghetti. They're all straight, parallel, and packed in tight. There's almost no room for water to sneak in. That means you get low swelling. But in a loosely packed fiber, it's like a bowl of cooked spaghetti. The chains are all tangled and messy, creating all these little gaps and pockets. And that's where water molecules can just rush right in, causing really high swelling. So that internal structure, the spaghetti factor, has a direct impact on how our clothes behave. So let's put this to the test with some fabrics you definitely know. Okay, get a load of these numbers. Cotton, your everyday go-to, swells by about 40% in area. Pretty significant. But then look at visco. It swells by a whopping 67%. And on the total opposite end, you have something like silk, which only swells about 19%. These are huge differences, and they completely change how a fabric feels and performs when it gets wet. And this chart just makes it crystal clear. I mean, look at that difference. Viscose swells in area more than 3.5 times as much as silk does. That is the spaghetti principle right there in action. The source material actually explains this perfectly. It says that nylon is more oriented than viscose. So nylon has very little space between its molecular chains. That's our uncooked spaghetti. But viscose has high molecular space, our messy cooked spaghetti, which basically turns it into a sponge for water. And all of this brings us right back to where we started. We now have all the clues we need to solve the riddle of the fabric that makes itself waterproof. Okay, let's walk through this. Imagine a jacket made from a super tightly woven fabric, maybe a special kind of cotton. When it's dry, you can see the threads are woven together, just doing their thing. But here's the thing, no matter how tight that weave is, there are always going to be tiny, microscopic gaps, pores, between the threads. Normally, that's great for letting your skin breathe, but it also means water can get right through. But this is where the magic happens. The second a raindrop hits that fabric, those high-swelling fibers start soaking up the water. And as they do, they get wider. Remember that transverse swelling we talked about? They literally expand and push up against each other, slamming the doors shut on those tiny pores. And just like that, the fabric has used the water to build a shield against, well, the water. The swollen fibers have sealed all the gaps, making the material waterproof. It is an absolutely brilliant piece of natural engineering. So this isn't just some neat party trick for raincoats. This invisible force of swelling actually has a massive impact on pretty much every piece of clothing we use. Think about it. A fiber's ability to swell is what lets it absorb dye in the first place. That cooked spaghetti space opens up and lets the color flood in and lock into place. That's something called dye fastness, and it's the reason your favorite shirt doesn't fade after you wash it. Swelling also affects a fabric's stability, like how much it shrinks or stretches, the way it feels against your skin, and even how elastic it is. It's this fundamental property that's being used every day to create the fabrics we know and love. It just goes to show you, in the most ordinary objects around us, like a simple piece of fabric, there's this extraordinary world of science happening. It really makes you wonder, doesn't it? What other invisible forces are shaping the world we wear every single day?